Hello student, this is Suman Sharma from Sinidih and this is the next video for class 9 and the chapter is motion. As you all are watching that the motion letters are already dancing, I just love it. Now student, today we will study about equation of motion. Here is the topic, that equations of uniformly accelerated motion. Firstly, we will understand that what is this equation of motion. Students, we know that the initial velocity is written as small u, final velocity small v, time taken small t, acceleration and distance is equal to s. So, student, the relationship between initial velocity, final velocity, time taken, acceleration and distance travelled by the body is given by the equation of motion. So, the relationship between these quantities gives the equation of motion. And there are three equations of bodies moving with uniform acceleration. Means there are three equations of motion and we will solve all the three equations of motion mathematically now. So, the first equation of motion is here. Here is the first equation of motion, that is v is equal to u plus at. Here v is equal to final velocity, u is equal to initial velocity, a is the acceleration and t is the time taken. That means final velocity is equal to initial velocity plus acceleration multiplied with time. To prove this equation of motion mathematically, let us suppose that a body having the initial velocity u, moving with uniform acceleration a, and after time t, its final velocity is v. So this equation of motion is used to find the final velocity acquired by the body at any time t. Students, we know the formula of acceleration is equal to a is equal to change in velocity by time taken. And change in velocity is equal to final velocity minus initial velocity by time taken. Final velocity is equal to v and initial velocity is equal to u. So the formula for acceleration becomes a is equal to v minus u by t. Now student, we can put 1 in the denominator of acceleration. And when we cross multiply this like this, then it becomes at is equal to v minus u. When this quantity is multiplied with 1, then it becomes this. When we arrange this equation, then we get v is equal to u plus at. This is the first equation of motion. Now, student, we have to pay some attention here that due to the sign of acceleration, this equation of motion can also be applied in the case of retardation. So, you should be very careful about it. Okay, this is the first equation of motion. Now, in the next slide, there is second equation of motion. Here, the second equation of motion is s is equal to ut plus half at square. So, here u is the initial velocity, a is the uniform acceleration, s is the distance travelled by the time t. Now student, this equation of motion is used to find the distance travelled by the body moving in time t. And we know that in the case of uniform acceleration, we use this formula to find the average velocity. So average velocity is equal to initial velocity plus final velocity by 2. That is u plus v by 2. This is the formula for average velocity. And students, we know the formula of distance is equal to average velocity into time taken. So this is the average velocity into time taken. So in this equation, that is S is equal to u plus v by 2 multiplied with time. In this equation, we put the value from first equation of motion. That is S is equal to, here is the u, so we write it u plus. Now here is final velocity. From the first equation of motion, we know that final velocity is equal to u plus at. So in place of v, we write u plus at by 2, and the whole quantity is multiplied with time. So this equation becomes S is equal to 2u plus at by 2 multiplied with time. Now students, this equation can be solved as, here the t multiplied with 2u and again the t multiplied with at. So this becomes S is equal to 2ut plus at square by 2, and it can be written as S is equal to 2ut by 2 plus at square by 2. Here 2 is cancelled out here, and it becomes S is equal to ut plus half at square. This is the second equation of motion. In this way, we can solve the second equation of motion mathematically. Now, in the next slide, we will study about the third equation of motion. In solving the third equation of motion, we have to use both the first and second equation of motion. Here students, we know that the first equation of motion, that v is equal to u plus at. And we have to solve this equation of motion and find the expression for time. So it becomes v minus u is equal to at, and v minus u by a is equal to t. This is the expression for time, which is obtained from the first equation of motion. Now students, we know that the second equation of motion, that is S is equal to ut plus half at square. We have just solved it. Now we have to put the expression of time in this equation. So it becomes S is equal to u. In place of t, we write v minus u by a. V minus u by a plus 1 by 2 a v minus u by a whole square. Okay. Now we will solve it. S is equal to, here this can be solved as, again u is multiplied with v, again u is multiplied with u. So it becomes uv minus u square by a plus 1 by 2 a, and it can be written as v minus u whole square by a square. Now students, here a square can also be written as a into a, means acceleration into acceleration. That means here the acceleration can be cancelled out here. Okay, and it becomes like 2 in the second line actually. Okay, from this line we solve it. S is equal to uv minus u square by a plus 1 by 2 a, and after this line, this is actually the formula of a minus b whole square. So it can be written as v square plus u square minus 2uv by, here a square can be written as a into a. Now the acceleration is cancelled out here, and this equation becomes S is equal to uv minus u square by a plus v square plus u square minus 2uv by 2a. Now we have to solve it. That S is equal to 2a here, 2 uv minus u square plus v square plus u square minus 2uv. Now we will solve it like this. Here S is equal to 2uv minus 2u square plus v square plus u square minus 2uv by 2a. Now plus 2uv and minus 2uv is cancel out, and we have v square here minus 2u square and plus u square, that is minus u square by 2a. So the expression becomes like S is equal to v square minus u square by 2a, and when this 2a is multiplied with this distance, so it becomes 2as is equal to v square minus u square. This is the required third equation of motion. So student, you have to solve it clearly and you will understand it. After solving all the three equations of motion, in the next slide there is most important 3 points which you have to remember, because it is very useful while we are solving the numerical. Here the first point, if the acceleration start moving from rest, it means the object or any body initially at rest, that means its initial velocity is equal to 0. This is the first case. Second, if a body comes to rest, it means initially it is in motion and after that it comes to rest and finally it stops. When it stops, then its final velocity would be 0. Now third, if a body moves with uniform velocity, then its acceleration is equal to 0. You already know it in the last video. So this is the three most important points which you have to remember for solving the numerical. Now students, you have to practice all the three equations of motion, how to solve it mathematically and use it for solving the numerical. And I think students, this is enough for today. So keep practicing for the numerical, and thank you so much.